So in previous video, we discussed about how to calculate general solution of second degree differential equation. Okay. So if there is any differential equation of second degree, uh, so this is our second degree differential equation where this P1 and P2 are constant and this x is any function of x. Okay. Then the general solution will be y equals to y CF plus YPI. Okay. We already discussed how to calculate YCF means complementary function of any differential equation in previous video. Okay. So in this video, I will discuss how to calculate particular integral for any particular case of any given differential equation. So before going to discuss how to calculate particular integral, so let me discuss this that if there is any second order differential equation given, we can write this differential equation in this form f of dy equals to x. Okay, and yp means particular integral will be 1 by f of d into x. This f of d is known as d operator here, and this x can be any function. So this x can be exponential function. It can be any trigonometric function like sine ax or cos ax, or it can be a polynomial also like x square plus x plus 1. So let me discuss how to calculate particular integral if this x is a only exponential function. So if x is a exponential function in the form of e to the power ax, then particular integral will be 1 by f of d into e to the power ax. Okay. And if f of a is not equals to 0, then it will be e to the power ax by f of a. But if f of a is 0 and also if dash a is not equals to 0, then the particular integral will be x into e to the power ax divided by f dash a. Okay. And also, if f of a and f dash a equals to 0, but if double dash a is not equals to 0, then the particular integral will be x square e to the power ax divided by f double dash a. Because after that, because it's a second order differential equation, so highest index value of d, it will be 2. Okay. So each and every function is in the form of this. So if we derivative this function once, so it will be first degree equation. And if we derivative this function twice, it will be a constant. Okay. So now try to understand this with few examples. Okay. So the given equation is d square d2y dx2 equals to e to the power minus 2. We have to find the general solution of this given differential equation. So since this x is the only function, only exponential function, there is no other trigonometric function or polynomial. So we can apply this method to find particular integral. Okay. So the given differential equation is d2y dx2 equals to e to the power minus 2x. Okay. So we can first find the YCF means complementary function in this way. Here the auxiliary equation will be n square equals to 0, because we know that when we calculate the complementary function, we have to take this x part equals to 0 to make the given equation is a homogeneous differential equation. Okay. So if we make the given differential equation to a homogeneous equation, so it will be n square equals to 0. So therefore the value of m will be 0 and 0. So therefore the complementary function YCF, it will be C1 plus C2x into e to the power 0x. We know that the value of e to the power 0 is 1. So it will be C1 plus C2x. Okay. So I hope this part is clear. Now, how to find particular integral for this problem? Okay. So first we have to write the given differential equation in this form: d square y equals to e to the power minus 2x. So therefore, the ypi will be 1 by f of d. Here the f of d is basically this d operator. Here the d operator will be d square. So ypi will be 1 by d square into e to the power minus 2x. Okay. Now we know that if we put minus 2 here, if we replace this d by minus 2, it will be a non-zero value. So we can directly put the value here, minus 2 whole square e to the power minus 2x. So our particular integral will be e to the power minus 2x divided by 4. Okay. So therefore, for this problem, the general solution will be y equals to ycf plus ypi, and we already calculate ycf. Here c1 plus c2x plus ypi is e to the power minus 2x by 4. So this is our general solution, and here you have to write that c1, c2, c1 and c2 being an arbitrary constant. Okay. Now pause this video and similarly try to find the solution for second one. Okay. Okay. So the second differential equation is this. So I know all of you can calculate the complementary function. So now it's your job to find complementary function. You can easily find auxiliary equation, then find the root of the auxiliary equation, and from the root you can easily find the complementary function. Now let me just explain how to calculate particular integral for this problem. Okay. Now here we can write the given differential equation in the form of d square y minus 4 dy plus 3y equals to 2 e to the power 3x. Okay. So we can also write here d square minus 4d plus 3y equals to 2 e to the power 3x. Okay. Now here this function of d is known as d operator here. Okay. So therefore the particular integral ypi will be 1 by f of d. Our f of d is d square minus 4d plus 3 into 2 into e to the power 3x. Okay. So this 2 is basically a constant. So we can write 2 here. So 2 into 1 by d square minus 4d plus 3 into e to the power 3x. Okay. So here the value of a is basically 3. So if we put 3 here, so it will be, let me calculate roughly. So it will be 3 square minus 4 into 3 plus 3. So it will be 0. Okay. So what we can do here, we can write x 1 by derivative of this function. So if we derivative this function with respect to d, it will be 2d minus 4 e to the power 3x. Okay. This is the second rule. Now we have to check roughly that is this d operator is 0 if we put d equals to 3 here or not. Okay. So if we put 3 here, it will be 2 into 3 minus 4. So this is basically a non-zero value. Okay. So in next step, we can directly write 1 by 2 into 3 minus 4 e to the power 3x. So our particular integral will be 2x e to the power 3x by 2. And if we simplify this, the solution will be x into e to the power 3x. So our general solution will be ycf plus y pi, means x into e to the power 3x. Okay. Okay. Now pause this video and try to find the general solution for this differential equation. Okay. So the complementary function to calculate complementary function, first we have to calculate the auxiliary equation. So auxiliary equation of the given differential equation 1 is m square, because we know that in the place of second order derivative we have to write m square, to m in the place of first order derivative we have to write m plus 1 equals to 0. Because to calculate complementary function, we have to first make the given differential equation as a homogeneous differential equation. For that, we have to take this Rx equals to, or the x part equals to 0. Okay. So the given auxiliary equation, this auxiliary equation is m minus 1 whole square equals to 0. So the value of m is 1 and 1. Okay. So therefore, the complementary function YCF will be C1 plus C2x into e to the power 1x. So basically e to the power x. Now it's time to calculate the particular integral. So particular integral will be, so if we write the given differential equation in the form of d operator, it will be d square minus 2d plus 1 y equals to e to the power x. So we can write ypi equals to 1 by f of d. So f of d will be this function of d, means d square minus 2d plus 1 into e to the power x. Okay. Now, if we calculate f of a, here the value of a is, 1. So our f of d is d square minus 2d plus 1. Now if we put 1 here, it will be 1 minus 2 plus 1. So this value is 0. So we can't put f of a here. For that, we can apply the second rule. It will be h 1 by the derivative of this d operator with respect to d. So it will be 2d minus 2 e to the power x. Now, if the d operator is 2d minus 2, and if we put 1, means here the value of a equals to 1. So if we put 1 here, it will be 0 again. Okay. So what we can do here? Derivative of this function. So it will be 2 into e to the power x. Okay. So our particular integral will be x square e to the power x by 2. So therefore, the general solution of the given differential equation will be y equals to YCF plus YPI. So our YCF is C1 plus C2x into e to the power x and ypi is x square e to the power x by 2. And you have to mention here that c1, c2 are arbitrary constant. Okay, so you can if there is any differential equation, second order differential equation given where the right hand side part is a only function of exponential, then we can use this method.